Welcome to this video on sequences. Okay, now this is just an introduction where we're looking at three types of sequence that you need to be familiar with. So they are an arithmetic sequence, or sometimes called a linear sequence, a geometric sequence, and a quadratic sequence. Okay, in later videos we're going to learn more about how to find these rules when we're given a sequence. But to start with, we're going to generate the first four terms of these sequences from their rules. Okay, and then identify which group of sequence they belong to. Okay, so the first one is 7n minus 4. Well, n is simply the position in the sequence. So the first term n is 1, the second term means n is 2, and the third term n is 3, and so on. So we need four terms, so we need to make n equal to 1, 2, 3, and then 4, and substitute it into each expression. So for the first one, 7 times 1 is 7, minus 4 is 3. Okay. The second term, 7 times 2 is 14, take away 4 is 10. The third one, 7 times 3 is 21, take away 4 is 17. And the fourth term, 7 times 4 is 28, take away 4 is 24. Now that is a linear sequence. Okay, and the reason we know that is because it's going up in equal steps of 7 each time. Okay, and it would carry on going up in sevens. Okay, it's also called an arithmetic sequence. The second one here, slightly more complicated rule. So the first term is going to be when n is 1. So 15 take away 2/3 of 1 is like 15 take away 2/3, which is 14 1/3. I'm actually going to write it as a mixed number because it's easier to work with in this example. Okay, the second term when n is 2, you're going to do 15 take away 2 lots of 2/3, which is 15 take away 4/3, which is 13 2/3. Okay, the third term is going to be when n is 3. So I'm going to do 15 take away 2/3 times 3. Well, 2/3 times 3 is 2. So 15 take away 2 is 13. Okay, and one more term. When n is 4, we're going to have 15 take away 2/3 of 4 is 8/3. So it's like 15 take away 8/3, or 15 take away 2 2/3, which would be 12 1/3. Okay. Now, if you look carefully at that sequence, you can see it's also an arithmetic or linear sequence because it's going down by 2/3 each time. Okay, it's going down by 2/3 to get to 13 and down by another 2/3 to get to 12 1/3. So that's also an arithmetic sequence. So both of these two are arithmetic. Okay, so I'll just put that there. Okay, and I shall write arithmetic. Now, in the next two sequences, we have an n squared term. Okay, now we do the same thing. We take n to be 1, 2, 3, and 4 in turn. So we'll start with 1. And in this one, we've got 1 squared, which is 1 plus 3 ones. That's 3. So 1 plus 3 is 4. Minus 1 is 3. Okay. Second term, n is 2. 2 squared is 4 plus 3 2s are 6. That's 10 so far. Take away 1 is 9. Okay. Third term, n squared is 3. 3 squared is 9. Plus 3 times 3 is another 9. That's 18. Take away 1 is 17. Okay. And the fourth term, 4 squared is 16, plus 3 4s are 12. 16 and 12 makes 28. Take away 1, 27. Now what you'll notice now, this is not an arithmetic sequence. It is a quadratic sequence, and the clue there is that the differences, and I'm actually going to write them in, are changing by a regular amount. In fact, the differences, which are 6, you see, then 8, and then 10, the differences form an arithmetic sequence, but the original sequence is quadratic. Okay. Now we go to the next one, and this is another quadratic sequence because it contains an n squared term, but let's have a look at what happens with the terms in this one. Now this is a bit more complicated because of this quarter here, but we basically got 100 minus a quarter of 1 squared. Well, a quarter of 1 squared is a quarter, so it's 100, take away a quarter, which is 99 and 3/4, take away 1, which is 98 and 3/4. Now again, I'm going to leave it in mixed number form at the moment. Okay, I could change it to a decimal, or I could change it to an improper fraction, but I'll leave it like this for the moment. Okay, now the second term, when n is 2, well, 2 squared is 4, and a quarter of 4 is 1, so it's going to be 100, take away 1, which is 99, take away the n, which is 2, 97. Okay, exactly 97. Now the third term in this one is going to be when n is 3. So I've got 100 minus a quarter of 3 squared. Well, 3 squared is 9. So a quarter of 9 is 2 1/4. So I've got to do 100, take away 2 1/4, take away another 3, so I'm taking away 5 1/4 from 100, which is going to leave me with 94 3/4. Okay, 94 3/4. And finally, the fourth term, when n is 4, well, that's going to be 100 take away a quarter of 4 squared. Well, 4 squared is 16. A quarter of 16 is 4. So it's 100 take away 4, take away 4, because n is also 4. So it's going to be 100 take away 8, which is 92. Now, not as easy to see what's going on there, but again, if you look at the what we call the first difference, that's the difference between the terms. If I go back to yellow again, the difference there is 1 3/4. In fact, it's negative 1 3/4 because it's going down, but I'll just put the actual difference, which is 1 3/4. Then we go to here and we see that the difference is now 2 1/4. Okay, between 97 and 94 3/4. Okay, it's 2 1/4. And the difference between the next two here is actually from 94 3/4 to 92. There's a gap there of 2 3/4. Okay, now hopefully you can see that the differences between those is constant, because that's going up by a half, that's going up by a half. Okay, so that's another quadratic sequence, because the first difference, the sequence of the first differences has a common difference between those. Okay, so those are both quadratic sequences. Okay, both of those. So let's just put that there, and quadratic. Okay, and the clue, as I said, was in the fact that they contain an n squared term. All right. Now, the last two, the n seems to be featured as a power of another number. Okay, so let's see what happens when we explore these. So the first one, again, we apply n to be 1, 2, 3 and 4. So starting with 1, 2 to the 1 is 2, 2 over 5 is 2/5. Okay, that's the first term. The second term, when n is 2, well, 2 to the power of 2 is 4, so it's 4/5. Okay, the third term is 2 to the power of 3, which is 8, 2 cubed, so it's 8/5. Okay, and the next term is 2 to the power of 4, which is 16, and it's 16/5. Okay, now hopefully you can see what's happening there. There isn't a common difference, but what we do have is a common multiplier between each pair of terms. So if we went from one term to the next, we're not adding something on, but we're multiplying. In fact, we're doubling the numerator each time. Okay, so the numerator is being doubled each time. So I could just put here times 2, times 2, times 2, referring to the numerators. Okay, and I would do the next one would be 32 over 5, 64 over 5, and so on. All right, that's an example of a geometric sequence. The next one also contains a power of n, a power of a number where n is featured in that power. So what we have here is 100 divided by 4 to the power of 1 more than n. So the first term is going to be when n is 1. So it's 100 over 4 to the power of 2, you see, because it's 1 plus 1. So 100 over 4 squared is 100 over 16. So it's 100 over 16, the first term. Okay, now the second term, when n is 2, it's going to be 100 over 4 to the power of 3, which is 100 over 64. Okay, and the next term is going to occur when n is 3, and it's going to be 100 over 4 to the power of 3 plus 1, which is 4 to the power of 4, okay, which is 256. So it's 100 over 256. Okay, and the last term, the fourth term rather, because of course there could be many, many more, the fourth term is 100 over 4 to the power of 4 plus 1, which is 4 to the power of 5, and 4 to the power of 5 is 1024. So it's 100 over 1024. Okay, this is another example of a geometric sequence, and this time, well, the denominators are getting 4 times bigger each time, okay, but because it's the denominators that are affected in this one, so that's times 4 times 4 times 4, what it means is that the actual value of each term is getting 4 times smaller. Because if you increase the denominator of a fraction by 4 times, you make the value of the whole thing a quarter of what it was before. So basically, you're dividing each term by 4 to get the next one. That's what it actually means. Okay, so those last two are both examples of geometric sequences. Okay. Now in the next video we will look at finding the rule for a sequence given the first, say, 4 or 5 numbers in the sequence. That's quite straightforward with linear sequences or arithmetic sequences, a bit more difficult with quadratics and geometric. So we'll do those in later videos. Okay, thank you for watching.